Hi, I'm Jay Faulkner. I'm an open source developer with G Research open source software, and I've been working on OpenStack Ironic for over 10 years. I wanted to take just a few minutes today to talk a little bit about the PTG that we recently held the end of October 2024. During this PTG, we planned the Epoxy integrated release of OpenStack, or also known as 2025.1. During this video, I'm going to give you a little bit of an overview of what the PTG is, what we discussed there, and then finally we're going to talk about how you can get involved in this work. So first of all, the PTG itself is the project teams gathering. It's an Open Infrastructure Foundation event where we get community groups together, open source project teams, all sorts of stuff. It used to be mostly in person. Nowadays, it's pretty much exclusively virtual, but we get together and we plan the next work. If you've ever been on a work retreat or any sort of thing where, you and a bunch of smart people go lock yourself in a room for a few hours and figure stuff out, this is essentially what the PTG is. It's an entire week of people getting together, talking about different topics related to their open source project. And most projects come out with a plan for the next 6 months from that. So just to sort of give you an idea of how it works, we have the project teams gathering page, and up here at the top, you're going to see that we have currently at the PTG. You're obviously not going to see a lot here because we're not having a PTG currently, but you can see the schedule from the old one, where you can see we have scheduled based on UTC times, different segments for each different team that has opted in. And sometimes, like with this, you can see it doesn't always have to be a project team or mapped to an open source project. We can have pop-up team meetings. We can have just meetings around a topic, like there was a session on eventlet removal. These sort of things happen here all the time. But the big trick about the PTG is in OpenStack, we often use these things called Etherpads to do coordination. And an Etherpad is sort of like a Google Doc or similar type of construct where you can have multiple people inside of a text document editing it together. This is where all the notes for the PTG are taken. One of the interesting things about this, I also would say, is the PTG itself has lots of conversations, lots of useful synchronous chat, but the reality is that most of what comes out of this is in this document right here. The things that we say in these meetings get forgotten over weeks and months, but we'll go back and refer to these notes several times to see what we discussed, to see if there were decisions made, to try to see why we maybe went left instead of right on a certain technical decision. And I'm obviously not going to read over all of this. I'm going to show you we actually have a more concise version of this, but just to show you how significant this is, you can see there's a whole lot of notes we've got here, all written about various ironic stuff that we want to work on this cycle. So I don't know if you're listening to this and you're a person who's ever participated in a PTG. I would go ahead and give you a little tip here, which is that make sure that you're in the Etherpad. Being in the Etherpad, editing, making sure that the things that you say with your voice are also reflected in notes and text is incredibly important if you want those to have a long-term impact. So in Ironic, because we know that our end users don't really want to dig through a bunch of our technical notes written in, kind of project shorthand. And so we create this item called our 2025.1 project work item spec. So I'm just going to caveat this by saying this is an unmerged version of this. This is kind of the proposed version. I don't anticipate it will change a lot, but just letting you know that, you can actually see up here, it says it's a dev version because this is actually built from a dev copy of the Ironic specs. But we'll go through some of these work items. And the thing we're going to have is we're going to have a name of the item. We're going to have a type of category. We have some bug fixes, some features, some maintenance items. A link to track them, which usually is just a bug ticket, and the people who are championing it. One important thing to note is when we talk about someone who's championing a feature or one of these work items, that doesn't mean that person has to do the work. That doesn't mean that person's the only person that's going to do the work. What it does mean is that that person is the one who's maybe the subject matter expert, maybe a person who's going to drive results on that. So even if you're not writing the code, maybe you're committing to review it or committing to mentor someone who is. But it's, sort of think of it as you're the engine that's pushing it along, if you're the champion, but that, don't come knocking on this person's door and asking them why the feature's not done, because this isn't a promise. That's the other thing, is that these are all just plans. We're hoping to get this stuff done, but the reality is that most developers who work on Ironic, work on other open source projects, have downstream responsibilities. This isn't really the only thing we're doing. So we're trying to come up with a list of stuff that we want to make progress toward this cycle. Now, I actually tell you, last cycle, we got, I think, all but 2 things on our list completely done. So we've got a pretty good record of this, but just, don't make any concrete plans based on the things we say we're going to try to do. If it's important to you to get it done, it gets done quickly, then I suggest you engage with the community, and we can talk about that. We can talk about timing, and if there's anywhere that you can maybe plug in and help us get it done. But we're going to go through these one by one real quick, and I'm going to give you the quick high-level summary of what each of these goals are and what they're for, like why we're doing it, maybe a little bit of context around it. So first of all, we're talking about Redfish consoles. For a long time, Ironic's had support for IPMI-based serial consoles. In fact, we used to have a really good system which plugged into something called Shell in a Box. But sadly, Shell in a Box is not really maintained anymore. IPMI is no longer the real darling of BMC access. In fact, we never really liked it, but at least now there are alternatives, right? And the other thing that came out in this technical discussion, which I found really interesting and I wasn't familiar with at all, is that simply by hooking up output to a serial console on some of these more performant, newer servers, you can actually limit the performance of the overall machine quite a bit. You sucking down some CPU usage just to output logs or consoles to a serial console. So what we're moving to is we're going to work to interface with the Redfish standard console, which is a graphical console provided over KVM over IP. And we're going to be working on adding support for these consoles over the coming months. We have a few neat little features that we're going to make sure are in there. We're going to make sure there's a read-only mode, because we know for a lot of operators, you might need to troubleshoot or see output from a console, but security policies may not permit you to interact with that console while it's got data on it. So that's one of the many things we're trying to think of. If you've got ideas in this realm, please reach out to us. We're going to be looking at OCI URLs to support container image files. So essentially right now, if you're passing an image to Ironic, for instance, if you're using Ironic integrated with the rest of OpenStack, then you're probably not even thinking about this. Nova's putting a glance image UID into that field, and you never have to think about where your images come from. But for our standalone users, they often have to spin up a separate HTTPS cloud, or not cloud, but just a server to host up these images to point Ironic at. This isn't ideal, especially given that a lot of the people who are deploying Ironic standalone these days are doing it to enable a container-based workflow. So what we're going to be working on is adding support for OCI container URLs in addition to HTTP, HTTPS glance URLs that we already support. Now, again, this feature is in progress. I'm not sure that the actual URL format we end up with will be OCI://, but this is the direction we're going. We want you to be able to point this at a container registry in the same way that you could point a tool like Podman or Docker to a container registry, and then they would be able to download images from there. One thing I'll note, and this is something that I didn't really understand until we started talking about this feature, is that this doesn't necessarily mean we're going to deploy any image from a container. What it does mean is that the OCI format, the kind of packaging format that those container images go in, can actually just hold QCOW files. So the idea here is that you would still have a special image for your bare metal, but you would be using the OCI, you'd be using the container registry as like a transport layer for that. But this next one is more along the lines of what you might have expected when you heard that, and that's supporting container-based deployment via bootc. And so essentially Bootsy is a tool that's kind of emerged in the cloud ecosystem that allows you to adapt a container to run on bare metal. And we're going to be looking to implement that tool in Ironic over the coming months. That spec is actually in progress right now. So if you're seeing this shortly after it's posted and you're interested in giving some input, go have a look at that at reviews.opendev.org and just search for Ironic specs. Next up will be Project Mercury. So essentially, this is sort of going to that integrated Ironic versus standalone Ironic split we were talking about, where, if you have Ironic integrated with a larger OpenStack cloud, your networking is being handled by Neutron, and it's probably doing a great job for you. But what we see is that some people are deploying Ironic and they don't want to have to deploy these other pieces, or maybe they have less of a need for a dynamic network, and all they need to do is switch between pre-existing VLANs or VXLAN interfaces, things like that. And so we're looking at this through Project Mercury. The reason this is sort of couched in a code name is that we're not exactly sure what it's going to look like yet. We're still forming what the use case of this are going to be, how it's going to work. We believe it's going to end up being Ironic talking to networking generic switch directly rather than talking to Neutron, which talks to networking generic switch. But that's still being specified. There actually is a working group being spun up around this for people who are interested in networking in standalone configurations or just in general advanced networking in Ironic. I'll make sure that a link to the mailing list thread about that is in our description. But essentially, we're just still trying to figure out the shape of this. And as we do, we're going to move it forward to try to make it where Ironic will be able to serve the needs of someone who's, say, needing to deploy to Kubernetes cluster, but doesn't want to deploy all of the OpenStack they need for the full bit. So next up is going to be inspection hooks for out-of-band inspection. Essentially, we are trying as hard as we can to not have another release of the Ironic inspector. We've been migrating off of this separate service for inspection for a while. We've obviously absorbed that functionality into Ironic Core. And the remaining piece is going to be inspection rules. And once that's done, then we'll have everything integrated in Ironic. And it'll enable us to do new things like this. Right now, we have these inspection hooks, which they sort of allow you to say, if you find this in my inspection data, then do this action. Where this action is usually just something as simple as putting a property or a trait on a node, something like that, just updating a piece of data there. So what we want to do is we want to enable those same type of hooks to happen on inspection data that we get from out of band, mostly from Redfish now. So if we get some information from Redfish and we need to take action on it, we'll be able to, and that's something that we're looking at supporting in the coming months. Next up will be the Kia DHCP backend. If you're a person who knows stuff about DHCP, first of all, I'm sorry. But secondly, you probably know that the Internet Systems Consortium's DHCP server, ISC DHCP server, is deprecated at this point and is not really an alternative. We've never used that in Ironic. We've always used DNS mask. But essentially, DNS mask is sort of a dependency single point of failure in multiple ways. It's generally a single person project, and we only have one backend that talks to DNS mask. This is a lot of risk for a large project to take on. So what we want to do is add a second backend so that we can have multiple DHCP providers to switch from. And like I said, ISC DHCP server is gone. So what's in its place? Well, Kia is the new one. And we'll be looking to add support in Ironic's DHCP interface natively for our standalone users, support for Kia. And then later on, we'll be working with the Neutron team to implement support for Kia in the Neutron DHCP agent, which is how DHCP is configured if you're using Ironic in an integrated use case. This is one of the cooler ones, I think, and this is coming out of our Metal 3 community. So thanks, Adam, from the Metal 3 community for bringing this up to us. But this is going to be in-band disk encryption using LUKS, the Linux Unified Key Setup. So if you've ever done encrypted disks on Linux, on a desktop, on a server, you're almost certainly using LUKS if it's not being hardware assisted. And so the idea here is we want the Ironic Python agent to be able to provision you an encrypted root volume that's encrypted with a key that's stored in the TPM. And so that's exciting for people who need things to be encrypted at rest, but maybe don't have hardware assistance to do that. Next up, improve OEM handling in Sushi. This is kind of a weird one, sort of some internals here, but I'm gonna take it out to the end of the road where maybe you'll see where the benefit will eventually come. Right now, we've stuck really hard to trying to make Sushi implement the standard Redfish implementation. But the real world's messy. Not everything fits inside of the things that Redfish has standardized. And for these, there are these OEM pathways, these OEM endpoints. Today, Sushi is configured to support those OEM endpoints only through a third-party plugin. And in practice, the only one of those plugins that got written was the one for Sushi OEM Track. Now, this has not been extremely well maintained. And what we're sort of seeing and we're realizing is that with Redfish becoming so ubiquitous, that we're going to have to take on some of that effort to bring that OEM logic directly into Sushi so that we'll be able to make good decisions about what to do depending on the OEM or expose maybe some OEM specific functionality. Now, the first steps of this is just internally. We want to get rid of Sushi OEM Track. We want that repo to be gone. We want to rework Sushi to make it easier to do this stuff. But at the end game here, probably not this release, but soon, is we want you to be able to do interesting custom things in cleaning with your Redfish endpoint. So if you've got some sort of OEM, some sort of specific setting in your Redfish that you need to toggle during cleaning, this is sort of part of the scaffolding we're building that'll lead up to that feature. So stay tuned. Similarly, and I think we're getting into the stuff that's a little bit more internal for Ironic, so not necessarily super user-facing, but it's still interesting stuff. We've got API response schema validation and an Open API spec coming. So if you're an old school guy like me, you might not have heard of Open API. It used to be known as Swagger. So if you've heard of like a Swagger definition for an API, this is what we're talking about. We're talking about Open API specifications. This is sort of the evolution of that. So the idea here is that we're going to take our API response schemas, we're going to revamp them a little bit, refactor them internally, make them a little bit more readable, a little bit easier to maintain for the developers, which is always nice. And as part of that, we'll be improving our testing around that. Always a good one as well. But once that's done, we're going to then be utilizing a tool that the OpenStack SDKs team has been working on that can read your code base and auto-generate an API spec based on that code base. So this is checking a lot of boxes to make things better for developers. We're going to clean up our microversion handling code in Ironic. We're going to add more integration tests to ensure we're handling microversions properly. And then we're going to be getting API reference for free. We're going to be getting that specification for free, which is great because even as we've been doing this process, we found really minor things here and there that were never documented properly. That's going to always happen in a big project. There's no amount of care you can take to prevent that outside of making the code do it. This is why we have linters running code. This is why all that stuff has to be automated because humans are unreliable, but computers are more reliable, or at least they reliably they reliably do what we tell them to. So that's exciting. This is another one that's very much just for the developers. There's a tool that a lot of Python projects, some OpenStack projects are using now called pre-commit, which sort of allows you to group a bunch of linting commands together, and it provides some scaffolding for you to be able to install a git pre-commit hook so that when you go to commit, it'll automatically check the linting on everything you're about to commit, but not the whole code base, which is pretty great if you're a developer and you're trying to get something checked out quickly. We also have integrated this into our typical Tox environment. So if you're a developer, you're used to just running Tox-E pep8 to get your linting run. That will still work after this is done. And this has already been done in the Ironic project proper, but we still have to trickle it down to the other Ironic related projects. But if you are willing to install the pre-commit hook by typing pre-commit install in the root of whatever repo you're working in that has a pre-commit config, it'll hook into your Git and let it run that commit hook, pre-commit hook. It's pretty great. I actually have a blog post about how you can template your repos to automatically set up pre-commit when you check out a new repo. I'll make sure that blog post is linked below in case you need that information. So we've got a couple more things here. We're almost done. The next one is a alternative to Tiny Core Linux for our IPA RAM disk for CI. So if you're just a user of Ironic, you may not know this, but we actually spin up miniature clouds inside of virtual machines hundreds, if not thousands of times a day to test Ironic. Every time a change is pushed, we're running something like 12 different clouds in 12 different configurations, all provisioning machines that are pretending to be bare metal. This is super cool. It's one of the greatest things about OpenStack that just some people are just not aware of. But running this many clouds means we have to be really resource conservative when we do it. And what that means is that we can't run, generally speaking, the same RAM disk that you might run on your servers in CI, because that has a lot of firmware in it that we just don't need in a virtual world. It's got a lot of stuff in it to manage hardware that just doesn't exist when you're working on a virtual machine that's pretending to be a bare metal server. So we've traditionally used this really slimmed down RAM disk built out of Tiny Core Linux we call Tiny IPA. This has worked well for us for a while, but there's a few problems with it that have sort of added up to being a bigger problem. That's they don't mirror over HTTPS. So every time we have to build one of those RAM disks, we're pulling it down over HTTP. Clearly not ideal. We have a very specific set of scripts that are used to build it that are basically just CI code. It's a big, hairy bash script, and we don't really have any other reason to have it but Tiny IPA. So it's not really giving us a lot of value to exist and to maintain that. And the other thing is that it does run an alternate libc. So, most Linux distributions are running glibc. There's a few other options. There's Muscle, there's ulibc, but we generally want to test against glibc because that's what all of our other stuff tests on. That's what our supported platforms use. That doesn't mean we want it to not work on other stuff. We obviously want our stuff to work everywhere. But for testing purposes, we really want to keep that aligned. And so all of these things add up to mean that Tiny IPA or Tiny Core Linux may not be the best choice for us anymore. And we're looking at making a Gen 2 based image using Disk Image Builder that'd be slimmed down. The advantage to you as the user to that is that we're going from a RAM disk in CI that's completely unacceptable for production use to at least creating one that'll be using Disk Image Builder, that'll have some minimalization in it that maybe you could modify it to create your own RAM disk that would be suitable for a production environment as long as you're okay with using Gen 2. And to be clear, we have and will continue to support other operating systems in our RAM disk. We test a CentOS based one in CI. I know that our friends over at Debian, Zigo, he does a great job of doing a Debian-based RAM disk for people who install over there. This is just for RCI, and as a Gen 2 contributor myself, I'm kind of excited about getting to use Gen 2 in my job and excited about maybe enabling some users out there to be able to run Gen 2 as their IPA RAM disk. And finally, we're going to retire Ironic lib. So Ironic lib, first of all, even though it says lib, it is a library. It's never been intended for use outside of Ironic. This is essentially an implementation detail of Ironic. We used to have a driver called the iSCSI driver where the conductor would actually be the one imaging the disk. So this meant that we had the iSCSI driver that needed all this disk image code in the conductor, and we had the agent which needs all that disk image code in the agent. And so we put that code in Ironic lib to share it. But what we found is when we were working on the CVEs last cycle, when we're kind of looking at how the shape of that library has changed since the iSCSI driver has been obsoleted and removed, we realized that we're sort of paying a big maintenance price to have a separate project, when in reality, the code shared is minimal. And what little bit of code is shared is the sort of thing that's not necessarily terrible to duplicate, like small helpers when calling execute and things like that. So we're going to make sure we factor out all uses to the Ironic lib library, and we don't expect to release one at the end of Epoxy. So the final release of Ironic Lib will likely happen sometime this cycle, maybe associated with a bug fix branch, depending on how far we are in the migration. So those are the things we're working on. Now, I promised at the beginning that I would tell you how you could get involved. And this is pretty simple. First of all, keep an eye out at the Open Infrastructure Foundation website. Look out for the next PTG. We embrace having operators come to our PTG. We want you there. We want your feedback there. We want to hear from you. So you're welcome to come. But even if it's not time for the PTG, hop into IRC. Go to irc.oftc.net, pound OpenStack Ironic, and join us. I'm JAYF in there. If you want to come, join, say hi. But you can come talk with us. Tell us what your use case is. Ask us any question about a feature that's ongoing. We want to have this conversation with you. Even if you're not using Ironic, it would be lots of fun to talk about how painful it can be to provision hardware using whatever tool you're doing, because we've seen just about everything that could happen. But you're welcome to come join us. Be invited. Come say hello. But for now, I'm Jay Faulkner with G Research Open Source Software. I'm going to let you go. Big thank you out to them again for enabling me to provide this content. I'm going to have a link in the description. We are hiring for positions in Dallas, Texas, and London, England, that are both related to OpenStack, and some operations positions that aren't. So I'm going to link that below. Please click it if you're looking for a job. G Research has been great to me. It's been a good place to work. I'm sure it'd be a good place for you as well. And just go ahead and make sure to indicate that the Gross Out podcast referred you or Jay Faulkner if you do that, so that folks can know where you came from. Again, thank you very much. I'm Jay Faulkner. Have a nice day.